Hello everyone, how are you guys? I hope you guys are doing extremely well. Today is the 16th day of my hashtag 30 days of talking to camera challenge, and the date today is 7th of August 2023. So before starting and getting to the topic, let us talk a little bit, because today I am feeling very happy. Not happy because something happened in my life, just happy because I have consistently uploaded the videos for 15 days. I have taken few days break in between, and that's probably the reason, because I was very ill and I was not in a condition to record the videos. But rather than that, each and every single day I have managed and I have tried my best to record a video. So that's really great. And now I feel very happy to see my videos. Like, I always, before uploading, I trim my videos, and previously I used to hate my voice. I hated myself seeing on camera my videos, my photos. I thought that I am not a photogenic person. I may not look good in videos. Now also I think like that a little bit, but you know uh, I really feels happy looking my videos, because I have done something consistently for many days, and I think it has built a discipline in me. So yeah. So till now we have discussed some searching algorithms, sorting algorithms, some problem based on searching and sorting algorithms. We have discussed types of linked list, what is a linked list, single linked list, and doubly linked list. So today we will be discussing about two topics, and after this the linked list chapter will be over. So the two topics which we will be covering today is circular linked list, and the other one is doublet singular linked list. So let's start the video. First, let's talk about circular linked list. So what is a circular linked list? Circular linked list is very similar to single linked list, rather in which in single linked list the last node, the pointer of the tail node, which is the last node, points to null, but in circular linked list the pointer of the tail node points to the head. Suppose you are like running in a circle in which you can't run backwards, you are running in a straight circle. Have you seen the dragon train or a roller coaster in a fair, right? So in what happens there is, like, the head of the dragon, it always moves in a circle continuously. It can't go backwards, it can only move in the circular path. So a similar concept is also used in a singular circular linked list. We have to note one thing, that in circular linked list we can insert at the end and remove nodes at the head in constant time. These two operations efficiently makes it appropriate for use it as a queue. So we can implement queue with the use of a circular linked list. Now think that in circular linked list, node is just like normal node in a singular linked list, but the last element node next always points to the first node of the list. I hope this was clear. Now how we can insert an element in the front. See, what's the structure of the circular link? What's the structure of the circular linked list? In circular linked list, the head points to the first element. So the head is the first element, then second, then third, then fourth, and then suppose this fourth element is the tail. Now this tail will again point to the first element, and likewise it's like in a circular manner, like a bangle. You can imagine any circular object, not necessarily a bangle. You can imagine anything of your wish, a wheel or anything. So how we will do that? Now the head is the first element. If there is no element, then I will simply take a node, and the next of this node will, previously the next of the node is pointing to null, but now the next of this node will have the data of this node only. Not getting? Let me explain one more time. Suppose no head is present, that is no linked list is present there. So we will take a new node, the node which we have to insert. I have already told in the previous video that inserting a node in a linked list is same as creating the linked list. How we create a linked list? We create a linked list by inserting many nodes. Sorry for the disturbance. I don't know who was playing the bell outside, so sorry for the inconvenience caused in the audio. But let's jump back again to our topic. Now since we know that inserting means creating, so suppose there is no linked list. So first I will take one node, and this node will have two pointers. One is value and the one is next. So this next points the address of the next node. So in this case, since it is circular, previously it was storing null in it, that is, it was pointing to null, but now it will point to its own address, the address of this node only. So I can say that I remember my own address. That node will say that, okay, I remember my own address. in English what happens is each node remember the address of its next node. But in circular English, if there is only one node, then that node will remember the address of itself. I hope this situation was clear. Now let's understand one more point, that what if we have to insert it in any other position. Before jumping directly into that, let's talk about a little bit analysis of this problem, and then I will also first talk about like how to insert an element at the end of the linked list, and after that I will discuss the general case. I hope this makes more sense than like first discussing the beginning, inserting at beginning, then general case, then end. So first I'll consider the specific cases, and then I'll consider the general cases. So what the analysis of this problem? How we would approach this problem? First, we will create a node with given value and its next pointing to null. If the list is empty, then the tail of list will point to it. In addition, the next of node will point to itself. If the list is not empty, then the next of the new node will be the next of the tail. In addition, the next of the tail will start pointing to the new node. Thus, the new node is added to the head of the list. And likewise, we can insert a linked list in the beginning. Insert a node in the beginning of a circular linked list. What would the time complexity? Yes, the time complexity will be constant. Now let's talk about inserting an element at the end. How we will insert an element at the end? First, suppose we know that there are how many elements in the linked list. Suppose there are 4 elements in the linked list. Now we will traverse through the linked list until we come through an element, the next of which is pointing to the head of the linked list. Suppose there are few elements like 5, 4, 8, 3, 2, 1. Now we will iterate until I found that any element, the address of which is pointing to the head of the element. Now I know that this is the last element, and I have to insert a node after this element. Now what I would do is the next of last element will store. Now previously it was storing the address of the head, but now it would point towards the address of the new node, and the next of new node will point towards the address of the head. So in this way we can insert the node at the end, and a whole circular will be created. Adding a node at the end is similar as adding the node at the beginning. We just need to modify the tail pointer in the place of head pointer. Like previously we are modifying the head pointer, and now we will modify the tail pointer. And what would the time complexity? The time complexity would be same as the previous case, that is big of 1, that is constant time. Now how we can search an element in the linked list? Searching a particular value in the circular linked list is very simple, and it is very similar as we search the element in the singular linked list. We would simply iterate through the linked list, and we will see that if the value is present in the list or not, and the time complexity is big of n, because what if the element which we are trying to find is at the end of the linked list? So in that case we would need to traverse the whole linked list. So in that side the time complexity would be big of n. Now let's talk about one more problem. Print all the content of the linked list. So how we can print all the content of the linked list? This is also similar as the singular linked list. We would traverse through whole linked list and print all the elements one by one. In this way the whole elements of the linked list would be printed. What would be the time complexity? The time complexity would be big of n. End of list is not there, so we cannot check with null. In place of null, tail is used to check at the head of the linked list. So this is just a simple changes which we need to do in case of circular linked list instead of singular linked list. Now how we can remove an element from the front? So removing an element from the front is very simple, and it's like completely similar to the singular linked list case, because the front is not pointing to the head itself. Again, if the linked list is empty, then the front element will point to the head. And if the list is empty, then we don't have to do anything. If the linked list only contains one node, so we will delete that node. In all the other cases, the next node of the tail is same as tail, then it is a single node case. Mark the tail is null, like the case I have discussed right now. If it is not a single node case, then the point tail node next to the second node from the head. Suppose the tail was pointing to the head, now the tail would point to the second node, and head would not be pointing. There is nothing to point to the head, so head would automatically be deleted. The time complexity of this case will be big of 1. Yes, constant time complexity. As you have all known that insertion and deletion in the linked list take constant time complexity. Now suppose what if we have given a value and we have to remove that node? So how we would do? First we will find the node that needs to be removed. Only difference is that while traversing the list till the end, we will track the pointer till the place when we can find that node. And if the node that need to be removed is other than the tail node, then tail node pointer is not modified. If the node that need to be removed is tail node, then tail node pointer of the list will be modified. So what I have just read it from the book. So what we can understand from this? Suppose if the element which we need to delete is at the tail, so we would simply traverse and remove the tail. If it is in the head, so we don't need to do anything, we would simply delete that node. And suppose if it's at any position, like if I want to insert the third element, so what we would do is we would traverse the list 3 times, and now the second node would point to the fourth node, and the third node would automatically be deleted. So this would also take big of n time complexity, because as we have already discussed, if I want to delete the last node, then in that case I have to traverse through the whole linked list, so it would take big of n time complexity. I hope this was clear. This case is very important. This is a simple case, but it's very important to remember. Delete list. So how we can delete list? Delete list simply means removing all the elements of the linked list and deleting it. So what we can do is, since we already know that previously the head was pointing to the first node, now nothing is pointing to the first node, only the tail is pointing to the first node. So what we would do is, we would simply point the tail to null. If the tail is pointing to null, then nothing is pointing to head. If nothing is pointing to head, then nothing is pointing to the second node, and in this way whole linked list will be deleted. The time complexity is constant, because just pointing a tail to one node to null won't take any much time. So this is the constant time, and we could do in big of one time complexity. Now copy the circular linked list reverse. So how we could copy the circular linked list reverse? I guess I have discussed this problem in my previous video also. We would just add head. So suppose, if you have to copy in reverse order, yes, we would add head. Suppose there are four elements, 1, then 2, then 3, then 4, then again 1. So what I will do is, first I will take 1 and then print, and then copy it into my new linked list. Then I will take 2 and insert it at the beginning. Now 3, insert it at the beginning. 4, insert it at the beginning. 5, insert it at the beginning. So in this way we would have all the elements of this single linked list. And what if we have asked to copy all the elements in the reverse order, in the same order? Then we would simply add it in the tail. Previously we are inserting at the beginning, and now we would insert it at the end. That is, first element will come first, second will come at the tail, that is second, third will come at the second, and in this way we would have the linked list in the same order. Now I hope the circular linked list was clear. Circular linked list is very simple. Is only difference between a circular linked list and a singular linked list is, in singular linked list the tail is pointing to null, and in circular linked list the tail is pointing to the first node of the linked list. Now let's talk about our other topic for this video, that is doubly circular linked list. Now what is doubly circular linked list? In a doubly circular linked list there are 2 pointers in each node. These pointers are called previous and next, like I have discussed in doubly linked list. It's similar. The previous pointer of the node will point to the node before it, and the next pointer will point to the node next to the given node. The previous pointer of the first element points to the last node of the list, and the next pointer of the last node points to the first node of the list. I hope this makes sense. It's very clear. In doubly linked list we have few cases, few operations which we can perform in doubly linked list. First is 0 element case, second is only element case, that is only one element case, third is general case which will be applied to all list. And one more point that I would love to tell you all, that we should avoid using recursion in case of doubly linked list or in these types of problem, because recursion makes things much more harder. How we can create the node in the doubly circular linked list? The node in the doubly circular linked list is very similar to the node in doubly linked list. The only difference is that the previous pointer of the first node is pointing to the last node, and the next pointer of the last node is pointing to the first node. In doubly linked list, the previous pointer of the first node was pointing to head, and the next pointer of the last node was pointing to the tail, pointing to null, and in this case only the null and head is replaced by the first and the last node. It's very simple. Now how we can insert the node at the head? So how we can insert a node at the head? Suppose I want to insert a node in the head of a doubly circular linked list. So how we can do that? If the list is empty, that means there is no element in the list. So the next pointer and the previous pointer will show the same address. That is, both will point to the same node. Suppose this is a linked list. It has 3 parts. That is previous, value part, and the next part. So next will also point to this, and the previous will also point to this. So this is the empty case in which no element is present. Now what if there are many elements in the linked list? This case is also very simple. The next of the tail would point to this new node, and the previous of this new node will point to the tail. Previously the next of the tail was pointing to the first node, and the previous of first node was pointing to the tail. Now the next of tail will point to the new node, and the previous of new node will point to the tail, and the next of the new node will point to head, and the previous of head will point to tail. Here head means the first node. Understand it one more time. Previously the previous of the first node was pointing to tail. The previous of first node was pointing to tail, and the previous of and the next of tail was pointing to the first node. Now the next of tail will point to the new node, and the previous of first node will also point to the new node. The next of and the previous of new node will point to the head, and the next of new node will point to the tail. So in this case, we would insert an element in the front of the doubly linked list. Now you may have also guessed that how we can do insert in the end of the doubly linked list. Inserting a node at the beginning of a doubly linked list or inserting a node in the end of a doubly circular linked list, both the cases are similar. A new node is created, and if the list is empty, then head and tail will point to it, like I have already explained it before. The newly created new nodes next and previous also point to the new node, that is both its next and previous it point to itself only. Suppose I am the value and this is my next and this is my previous, so next will also point to me and the previous will also point to me. Previously both are pointed to the node previous and the next to it, that is the node at the right and the left position to it, and now both will point to itself only. If the list is not empty, then the pointers are adjusted and a new node is added to the end of the linked list. Only tail needs to be changed in this case. So the size of the list is increased by 1. In previous case also, so the size of the list increased by 1. And what is the time complexity of both these problems? The time complexity is constant, because I am just inserting a list and inserting a node, and inserting a node in the linked list takes constant time. All of us know, and I have been discussing it from the past 3-4 days. So I hope this was clear. I hope this concept is clear to you all. Now what is happening when I am inserting at the end? The next of the tail would point to this new node, and the previous of this new node will point to the next of the tail, and the previous of the tail will point to the head, and the next of head will point to the tail. This is the similar case. I hope this makes sense and this is clear. Now let's talk about how to delete the head of a linked list. Now if I want to delete the head of the linked list, that is delete the first node of the linked list. So if the list is empty, that is there is no element in the linked list, then we would simply return. In case of single node, then there is only one node, then the head and tail will store null, because previously the head is also pointing to itself and the tail is also pointing to itself. So the head will store null and the tail will store null, so nothing is having the address of the first node. So in this way the first node will be deleted. In all the other cases, the next of second last node will point to head, and the previous of head will point to second last node. I hope this is clear. So the next of the second last node means the node which is coming before head, so it will have the value of the previous of head. Sorry, I got a little bit confused. Yeah, so the next of the last node will now contain the value of the second node, and the previous value of second node will now contain the value of the last node, and in this way nothing is storing the value of the head, so that's why head will be deleted. What will the time complexity? Yes, the time complexity will be constant, that is big of n. Now let's talk about one more problem. Delete list, free a linked list. Simply we would delete complete list. Like it is very similar as the case of circular linked list. I don't think I need to discuss it every time. These are some small case, which these are similar, like I have discussed yesterday, also discussed in doubly linked list also, and in doubly single linked list also. These are very small and similar cases. All these cases are very similar to the cases which I have discussed in the case of circular linked list, that is singular circular linked list. Now how to search a value in the doubly circular linked list, that is also similar. How to print the print or doubly circular list is also similar. Just we will traverse through the whole linked list and we will just print the element. So I hope all this was clear. All the questions, all the problems, all the implements, all the approaches which I have tried to explain through the series of these 3 to 4 videos are clear. I know I am not able to explain it in very detail, explain it everything with code or visualize it, because my objective is not here to explain. My objective is here to just speak for camera for 30 days, because it is the 30 days talking to camera challenge. Speak to camera for 30 days and then speak in English, because I want to improve my English. Speaking in camera is itself a skill, and it's a difficult skill to master, because it requires a lot of practice and a lot of confidence. You may have seen some old videos of some famous YouTubers which you follow right now, and the current videos. You can see a lot of difference in how they spoke previously and how they spoke now. Doesn't matter the content also matters, but the art of speaking also improves with practice, and I am just doing the practice here of speaking in front of the camera. So I wanted to speak, but I have nothing to speak to, so I just decided to share anything that I am learning, anything about which I am knowing. I have been practicing some questions of English these few days, so I just decided to share those with you. If anyone comments or anyone of you watches the videos in further, like after 3 years or 4 years, any time, and if any one of you says that I want like a series of, or else I want some big problems like a hard level or medium level problems, then I will create one more video for it. And it also depends that after 3 or 4 years I am continuing YouTube or not. Probably I will continue YouTube because the fun and the love I am getting from recording myself every day and speaking on camera is really very great. So I appreciate all of you guys for supporting. If anyone is supporting, yesterday I got a comment and that comment made me very happy. So I hope today also someone comment on my video, or someone likes my video, or someone just give it a view, so I would know that YouTube is promoting my video. I don't really care if it's promoting, I will record it anyway. So don't know what I'm seeking. Thank you so much. I have already told you to skip these parts at the end. So the power is also cut and I don't think I have to speak more now. So yeah, thank you so much guys. Have a good night. Bye bye. Take care. All the best.